This is the video for Math 120, Section 3.1. We'll be studying derivative formulas that are really fast, so these kinds of exercises are going to be very quick. But we're going to need to know some formulas from algebra so that we can change things like number 4 to a form that we can differentiate with these new formulas we're adding today. In addition, we also need some formulas for radicals, for denominators, for e to the x. We have a constant added. We'll need the equation of the tangent line, which we've already talked about. There are some ones that, like number 11 here, that have a few questions that really have nothing to do with number 11 specifically. It says, when is the derivative of 0? And we've looked at graphs and said that happens when there's a high point or low point, or a maximum or a minimum. And at that point, the tangent is straight across. F prime is positive, that means the slope is going up. The graph is going up. So the f prime is the slope, the graph is going up, the slope is positive. So if the graph is going up, you should be able to answer this question. And this one says the slope is negative, and you should be able to answer that. Once you find a derivative, you can also find a second one. You just take the derivative of what you just had. So we do that for a couple of these problems. Again, we'll have to study the radicals and how to rewrite them first. The velocity is the first derivative, and the acceleration is the second derivative. We can do a question like this one, number 15, by putting this in our calculator and seeing when the tangent is horizontal. So that's the max and min. So second calc, that second trace, will give you a max and min option there with lower and upper bounds, and we'll do one of those. We do need the e to the x derivative. They want a second degree polynomial so that these things are true. We'll look at that, and then determine whether or not the statement's true or false. For questions like 20, you want to be a little bit careful because we're not going to have a formula for this yet. So number 21 is, note, this is the definition of the derivative, so they're asking you to take the derivative and put in 2. So a quick algebra review, we have a radical. If we write a radical this way or down like this, there are some ways that we can rewrite these. So that the root is actually what goes in the denominator, like the roots are underground. You want to think of that, it goes in the denominator. If I have something in the denominator, it can be written as a negative power. Just that easy. E to a power, we know that if we had this side, the right side, we could rewrite it to look like this. Well, the formula goes both ways. If you have something like the square root of 3x, you're going to need to separate those so that you can work with the square root separately. And as I said previously, the velocity is the first derivative and acceleration is the second. So let's review the algebra first. So some examples here. The cube root of x to the fifth is the same as writing x to the 5/3. The square root of x is the same as writing x to the 1/2. X squared, the fifth root of x squared, is the same as writing x to the 2/5. Note that the root goes in the denominator. The power was already there as a power. The root is the weird thing. This one, 3/7 is not attached to x, so I can write that separately. And x is to the negative 1 power. Negative 15 is not attached to x squared. This is negative 15, x to the negative 2. This is negative 7/2, x to the negative 4. Don't overthink these. Be really clear about how you're thinking these. Basically, this is a sort routine. 3 and 7s don't move. I don't need them to. But I need the x as a negative exponent so that I can apply my rule that I'm about to learn about derivatives. Same is true for each of these. So study those for a few minutes until they make sense and you don't make mistakes with them. These can be separated out. I'm going to write the e to the 5th first times e to the x. And here I'll write e to the negative 4th times e to the x. I do not need you to simplify this by taking it into your calculator and giving me approximation. I would prefer exact values. E to the negative 4th is an exact value. Here, in order to take the derivative with the formulas we learned today, I'll have to split this up. This is the square root of 5, square root of 5 times the square root of x, which I can write as the square root of 5, x to the 1/2. Same with this one. This is the square root of 14 times x to the 3/2. Square root means half power. Fifth root means fifth power. So the formulas for the derivative are here. The first few we'll learn. The derivative of a constant is 0. That makes sense because the derivative is the slope of the tangent. And if you have a constant formula like y is equal to 3, then the slope there would be 0. That's a horizontal line. The derivative of x is 1. And if you have a line y is equal to x, the slope of that line is 1. Rise of a run would be 1. Any function that we have we're taking the derivative of that has a constant in front of it, it can just be written as the constant times the function's derivative. Now we've worked with this already. The constant ended up being factored out in several locations when we were doing the x minus a formula. The derivative of x to the n, we've seen this, is n x to the n minus 1. If you've noticed the pattern, here it is. For the last two, if you can take the derivative of f and you can take the derivative of g, if you add them together, you can take them separately. If you subtract them, you can take them separately. So these are our first few formulas. We'll have a product rule and a quotient rule, but that comes in the next section. So this is what we're working with in this section. So we go back to the beginning. We want the derivative of a constant. Well, the derivative of a constant is 0. I will give you something like this, so be prepared for it. This is one of the most missed problems on the next test. Differentiate the function here. Well, the derivative of a constant is 0, and the derivative of negative 1/3 t would be negative 1/3. So we can see this is just the slope of the line. If we differentiate this function, the derivative of x cubed minus 4x is going to give me 3x to the second. So we're going to bring the power down to the front, 3x, and then raise it, lower it by 1. So it's 3x to the 3 minus 1, which gives me 2. And then the derivative of 4x, negative 4x plus 6, this part is just a line. So the slope of the line would be negative 4x. But the derivative of a constant times x would be just the constant, minus 4. These are really quick. This one we'll have to rewrite first, so I could write this as negative 13s to the negative 5th, and then take the derivative. Note that the variable here is s. So once you have negative 13s to the negative 5th. So I'll go back to my examples and take the derivative of these. If this is equal to y, then y prime would be 5/3 x to the negative, not negative, it'll be 5/3 minus 1, which is 2/3. Now this is using the rule, the derivative of x to the n, and that's what we mean by this. Take the derivative of x to the n, that's equal to nx to the n minus 1. So I did n 5/3 x to the 5/3 minus 1, which is 2/3. Now a trick with these is if you do 5 minus 3, that will give you the numerator. So these are pretty quick. If you're not understanding them because of fractions and you don't like fractions, then you might pick up your calculator and make sure that you're doing this correctly. The point is to have a procedure that works every time and gets you the correct answer. So for this one, if this was y, we'd have y prime is equal to 1/2 x to the negative 1/2. Sometimes I'll have you rewrite these. So if I had to rewrite this, this would be 1/2 squared of x. On this homework section, I don't think they ask you to simplify anything or to get rid of negative exponents, so this would be fine. For the next one, we have y prime is equal to 2/5 x to the negative, and we're going to do 2 minus 5, which gives me negative 3/5. This is 3/7 times this, so we'll have 3/7 times negative 1, which gives me negative 3/7 x to the negative 2. Negative 1 minus 2 gives me negative 2. This is the constant times the function rule. It'll be the constant times the derivative of the function. So negative 2 times negative 15 will give me, that's 30, I believe, x2. Now be careful when you have negative, because it's negative 2 minus 1, which gives me negative 3. Oops, this is y prime, this is y prime. Now be careful when you're doing these that you actually say y prime. If you leave off the y prime, I take off a point all the way to the final exam, because when it asks for the derivative of y is equal to something is y prime is equal to the derivative. So make sure you're writing that y prime. The derivative of y is y prime. So when we write this as y equals, and here I've been a little sloppy, so I really should have y equals here. Then when I look at the derivatives all the way down the page, then I have to write y prime. So the derivative of this would be y prime is equal to -4 times -7/2 is going to give me 14. Pick up your calculator if you need to. The 2's reduced. 2 times 7 gives me 14. X to the -4 minus 1 is -5. Now because I don't have the chain rule yet, and some of you have taken calculus and you've heard of the chain rule, I can't do this thing without actually knowing the chain rule, unless I separate it. So I've separated here. So my derivative, this part is just a constant. The derivative of e to the x is e to the x. So e to the x prime equals e to the x. So y prime will be e to the 5th times e to the x. Now here the same is true. We just have a constant. Y prime is equal to the constant times the derivative of e to the x. So this is constant. There's no x's in it. That's how we know it's constant. So this is e to the -4th times e to the x. The e to the x is really easy, but it's also easy to miss because it's too easy. On this one, I'll put it down here, y prime is equal to 1/2 times the square root of 5, x to the -1/2. So square root of 5 is just a constant, so I need the derivative of this. We generally do multiplying these two, which doesn't simplify, 1/2 times the square root of 5. And the square root of 5 is not in the denominator, be careful with that. And then I'm going to take the power down 1, x to the -1/2. So for the last one here, y prime is equal to 3/2 times square root of 14 times x to the 3 minus 2 gives me 1/2. 3 minus 2 gives me to the numerator. For right now, we also do not have a product rule. So if we have problems like this, we'll have to fold them out so that we have one straight set. Now this is x to the 1/2, so when I distribute the square root of x, I'll get x to the 1/2 plus 1 gives me x to the 3/2 minus 7x to the 1/2. So I'm thinking this here is x to the 1/2. This one is x to the 1 minus 7. So I'll multiply the powers, multiply these two, which means I add the powers, right? Note, if I'd given you x squared times x cubed, you wouldn't have had any trouble telling me x to the 5th. So all we're doing is adding those exponents. You know it, because this wouldn't give you trouble, but sometimes when you're working with fractions, you cause yourself a little trouble because you want to reinvent, make up some rules. You start making stuff up is what happens basically. These we want to think this is x cubed and this x to the 1/3. So when I rewrite this, this is x to the 3 plus 1/3. Well, 3 times 3 gives me 9. That'll be 10/3 plus 3x to the 3rd. And rewriting this one, we'll go back and take the derivatives in just a second. I need to FOIL this out. Do you remember FOIL? First, outer, inner, last. First would be these two. That gives me x to the 4th. Outer would be these two. That gives me minus 2x cubed. Inner are these two. That's plus 3x squared. And last are minus 2 times 3 gives me minus 6x. And I'll check that real quick. X to the 4th minus 2x cubed plus 3x squared minus 6x. So I know that I can combine like terms there, so I'll write x to the 4th minus, well, plus, minus 2 plus 1 of them gives me x squared minus 6x. So let's go back and take the derivatives. Y prime on this first one is 3/2, bring the power down, x to the subtract 1 from the power, and that would be 1/2. Minus 7 times 1/2 is 7/2, x to the 1/2 minus 1 is going to give me -1/2. Don't overthink these. It's a very straightforward formula. The formula says x to the n, take the derivative, is n x to the n minus 1. And if we have a constant there already, like here, we just multiply. We can study the theory of these and prove all the theorems from calculus, but it doesn't help just how you're doing it. It's just a pretty simple thing. It's like learning to drive a car. You don't really think about whether or not you have to turn the wheel when you're going around a corner. You just go ahead and do it. And that's what we're doing here. Make it automatic. For this one, y prime would be 10/3. X to the 10 minus 3 gives me 7/3. Plus 3 times 3 is 9. X to the 3 minus 1 gives me 2. And the last one here, y prime is equal to 4. X to the third plus 2x minus 6. And you can think of this as minus 6 times 1. This is the first power, 1 times 6. So negative 6. X to the 1 minus 0 is x to the 0. And note that x to the 0 is equal to 1. So we're done with those derivatives. So what we have are a set of derivatives. We have x to the n prime is equal to nx to the n minus 1. We have that a constant, the derivative of that is 0. We could also put in cx, which sometimes is the one you'll miss. Like here, the 6x, that's just equal to c. And then we can add them together, the f plus g prime, we got that. And the cf prime is equal to c times f prime. I usually ask these derivatives on the test, so be prepared to give me the derivatives. So there were a few that I needed to go over. Find an equation of the tangent line. Remember, we can do these in the calculator. You could take the derivative and put in 1 though. So if you took the derivative, you had 4x cubed minus 6x minus 1. You put the 1 in, you'll get your slope. But you know every single time I'm going to need to put the slope in here. M times x minus, in this case I have x1, that's 1, plus y1 plus 3. I already have that, so what I'm trying to do is figure out the slope. So either you could take the derivative and put it in, or you could go to your calculator, find the slope there, which is second trace, dy dx, that's 6, and put in, we want 1, and that gives me 9.004. Well, you can get rid of the 000 part because that's just error in your calculator. It allows a little bit of fluctuation there because it's done within an algorithm. So here our slope is just 1. I could write it, sorry, our slope isn't 1, it's 9. And my typical mistake is to put that 1 back in there. So make sure you're not following my mistake. I've done it, you don't have to think about it. Down here they're going to ask you for first and second derivatives. You'll have to rewrite this first. They want the velocity and the acceleration. So the velocity is just the first derivative of acceleration. And the second, they ask you to find the acceleration. That means put it in. Here they say when the velocity is 0. So you set the velocity to 0 and get the t, then put that t back in the acceleration. Tangent, horizontal tangent lines, if I wanted to here, I could find those. Second calc without putting that one in for you. On that mine, I know I had a minimum, so I'd put in minimum. I wanted left bound of maybe -2, and I could trace over there. So once I have -2, I really could trace over there and just get past that minimum and hit enter. And it doesn't matter what the guess is. So put an enter of a guess in, and the minimum occurs at 0.1637. Now I was expecting it to be at 0 because it looked like it was at 0, but this function is not centered around 0. So it didn't have a minimum at 0, it had it at a different place. So be sure you're not just picking stuff off the graph because they're going to give you ones that your minimum may not be just what it looks like it is. It might be slightly different. For this next one, they ask us to find a second degree polynomial. Well, that's y is equal to ax squared plus bx plus c. And we want these things to be true for it. So let's work this one out. So if p is equals, if the 0.13 is on there, then that means that when we put 1 in here, we get 3. So we got 3 equals to a times 1, which is a, plus b times 1, which is b, plus c. So we get that equation for the first one. P prime of 1 is equal to 4. So if I take the derivative, I get y prime is equal to 2ax plus b. So P prime of 1 is 4, means 4 is equal to 2 times a times 1. That would be 2a plus b. And then if I take the second derivative, because I need it for this one, that would give me 2a. So that gives me that 8 is equal to 2a, which tells me a is equal to 4. So I can plug these back in, or I could put this into my calculator in the matrix stuff. I don't need to, but I can put this back in now. So I get 4 is equal to 8 plus b, because a was 4, so 4 times 2 is 8 plus b, which implies that b is equal to negative 4, and I made a mistake, so I had to stop and start over. That's negative 4. So b is equal to negative 4. So once we have that b is equal to negative 4, we have 3 is equal to 4 minus 4 plus c, which implies that c is 3. So we have a, b, and c. We have 4x squared minus 4x plus 3. So y prime will be the derivative of this, which is 8x minus 4, and y double prime would be just 8. So we'll try these and make sure they work. If I put 1 in, I get 4 minus 4 gives me 0 is 3. So that's right. If I put 1 in here, 8 times 1 gives me 8 minus 4 gives me 4. That's right. And y double prime is 8. So we've gone through these for derivative formulas, and we had some algebra review with the radicals and powers and e to the x. We have one more that I'm going to do for you here, show you how to do. It's the line parallel to the line 3x minus y is equal to 5. So it says at what point is the curve here parallel to this line? Well, parallel means they have the same slope. So let's do this one on paper. If I have y is equal to 3 plus e to the x minus 3x, to get the slope out of this one, I take the derivative. Y prime is equal to 3. The derivative of 3 is, that's a constant, so that's 0. E to the x, the derivative is e to the x. And then the derivative of negative 3x is minus 3. That's our cx formula. So we use these formulas. The constant prime is equal to 0. E to the x prime is equal to e to the x. And cx prime is equal to c. Those are the formulas we use for the derivatives. Now over here on the slope, I need to have this in y equals mx form or mx plus b form, or just understand how I'm going to get the slope out of this. I could take the derivative. If I took the derivative, I'll get 3 minus y prime is equal to 0, which tells me y prime is equal to negative 3. So I could have taken the derivative to get the slope out of this one also, and then I'm setting these two slopes equal to each other. So the slope is negative 3. Alternatively, if I'd solve for y prime, for y, I get negative y is equal to negative 3x plus 5, which tells me that y is equal to 3x minus 5. So these should be the same slope, so that means that over here I made a mistake. This was negative y prime, because I moved it to those signs, so I get y prime is equal to 3. So be careful that you're not mixing up signs. I'm doing a pretty bad job of it for a few seconds here, but it's alright. So here I'm going to set these two equal, so this says e to the x minus 3 is equal to 3. Now I see these, and oftentimes I'll get a 0 here, and that's not right. So we have e to the x is equal to 3 plus 3 gives me 6, because I'm adding 3 to both sides. So that tells me that if I take the natural log of both sides, I get x equals the ln of 6. So my exact answer there is x is equal to the ln of 6. Now I want to know what the y value is, so because I wanted a point, y will be equal to 3 plus e to the ln of 6 minus 3 times 6. Well, e to the ln of 6, remember, pops that x out, so we get 3, and this would be 6. I said 6 and wrote x. How about that? 3 plus 6 minus 3 times, this should be ln of 6, 3 ln of 6, which gives me 9 minus 3 ln of 6. So my point here would be ln of 6, comma, 9 minus 3 ln of 6. That would be the exact point. Now, if I did this on my calculator, I want to know when the derivative is equal to the slope of that other line. Well, the derivative was e to the x minus 3, and the slope of the other line was 3. So I'll do second trace, and I want the intersection, which is 5. It looks like the first curve is there, the second curve is there, and then the guess, it really doesn't matter. It finds that the intersection is 1.79175. Now the 3 is the slope here. The x value is what I want. So I want to check to see that that actually is the natural log of 3, 1.79175. second quit. So natural log of 6 rather is 1.79. So this is my answer for the x. Over here, they didn't ask for an exact answer, and they may want to just say, well, I guess here it says round to 3 decimal places here. They didn't say that here. So 3 may be enough, 4 may be more. You may need as many as 4 or 5. So if you're going to use the decimal approximations from the calculator, and this is a decimal approximation, then you have to put it in that way. Now once I have that, what I want is the y of that. So I'd have to store that to x, and then do the y value would be 3 plus second e to the x minus 3x. So I'm putting this back into y because I want the y value. And this gives me 3.62472. So there are the approximations for the answers that I put on here. Natural log 6, 9 minus 3 natural log 6. Be sure to see me in my office hours if you need any help with any of this. That's what I'm here for. 11 hours a week are scheduled, and you can schedule times outside of that. My office hours are always written on emails to you, and the Zoom for office hours is also available there.